we're going to solve a rational equation. We have some rational expressions in there and in the denominators, and we want to get rid of those. So we're going to find the LCD and multiply the equation both sides by the LCD. We don't want to find the LCD and make them all the same LCD in the denominators. We don't want to do that. I want to emphasize that. We want to get rid of the fractions. So first step is we're going to find that LCD. So let's write that down as step 1. Okay, let's find that least common denominator. If I factor out everything that I have in the denominator for each one of these fractions, I'm going to notice that 4x is like 2 times 2 times x. And x plus 3, well, we can't factor that anymore, so I'm just going to copy down here an x plus 3. And then I notice that we have a 3x squared plus 9x, so we can factor out a 3, we can factor an x, and then we can have x plus 3 left over. So if we compare all of these factors, I'm going to need a factor of 2, factor of 2, factor of 3, 1 factor of x, and 1 factor of x plus 3. So that's my LCD right there. Let's multiply that out so we can see what this is. This is a 12. We have an x, and we have an x plus 3. Let's multiply the entire equation by that LCD. Okay, so we're going to call this step 2. Multiply the equation by the LCD. I'm going to draw some parentheses around the entire equation, and I'm going to write the LCD right next to these parentheses. So that's going to be multiplying by 12x, x plus 3. Maybe I should put these around inside square brackets so it's obvious I'm going to distribute this. Oh, I don't know how that one disappeared there. Let's distribute this to every single one of these rational expressions. Okay, so right here, I want to distribute LCD. Alright, I'm going to rewrite the LCD so it's factored out, and that way it's clear to everybody which factors we're going to divide out. The 12x times the x plus the quantity of x plus 3 is going to be written as 2 times 2 times 3 times x plus 3. And that's going to be multiplied with the 1, so it's going to be all over the 4x. I'm going to write that factored out. 2 times x. And then our next rational expression, once again I'm going to write it factored out. 2 times 2 times 3 times x plus 3. And that's all over the quantity x plus 3 is equal to 2 times 2 times 3 times x plus 3. And I'm going to write that denominator factored out, so it'll be 3 times x times the quantity x plus 3. Okay, let's see what factors we can divide out. It looks like we can divide out 2 factors of 2. There's imaginary ones left over. You can divide through by factor of x, and we're going to be left over with a factor of 3 and a factor of x plus 3. So we're going to have 3 times x plus 3, which I'm going to have to distribute, and I'll do that in just a second. Over here I'm going to divide through by a factor of x plus 3, and we'll have left over a factor of 2 times 2 times 3 times x. So that'll give me a 12x. And it looks like we can divide through here by a factor of x and a factor of 3. And every time we divide through, we're left with the imaginary factors of 1. So I'm going to write those ones down, just in case you see that everything is divided out, everything cancels out. You always have a 1 left over. And it looks like we're going to have a factor of 2, a factor of 2. So that'll give me a factor of 4 here. 4. Alright. Let's simplify this as much as we can, and then let's see what type of equation we're left with. This is going to give me 3x plus 9 minus 12x is equal to 4. I'm going to combine like terms. I'm going to combine my 3x here with this negative 12x. That will give me negative 9x, and then I'm going to subtract 9 to both sides of the equation. So I can see here I have a linear equation. I want to isolate my variable, and I'm going to do that by doing inverse operations. Since I'm adding 9 to the x term, we're going to subtract 9 to both sides, and we'll have negative 9x is equal to negative 5. Now we're going to divide both sides through by negative 9. Negative 9 divided into negative 9 is just going to give me a positive 1x, and negative 5 divided by negative 9 is going to give me a positive 5/9. Alright, now to be 100% sure that this is the solution, we do need to check this in the original equation. So now we're going to substitute this. So let's go back. I can't remember which step we're on now, but let's just say we're going to check this. So let's say check solution. And we're going to do that by substituting the solution into the original equation. Let's just say here, substitute solution, and we should call this a possible solution, because it might turn out that the solution might not work. So we'll say it's a possible solution. Substitute possible solution into original equation. Alright, every time I see an x, I'm going to substitute 5/9. So I can see I have an x here, I have an x here, I have an x here, and I have an x here. So let's go through and do that substitution now. 1 over 4 times, and I'm going to leave it empty for now. I'm going to use my red ink there so it really stands out. You can actually really see where I'm doing that substitution. 5/9, 5/9, 5/9, 5/9. Now this is going to be a little bit of work, right? Because we've got fractions here. We need to do a little bit of simplifying. So this is going to give me 1/29. It's a complex fraction, so we're going to have to simplify that. That's going to simplify to 9/20 minus 1/, I'm going to have to add 5/9 with 3, so I'm going to need a common denominator. So that's going to give me 5/9 plus 3 times 9 is 27/9 here. 5 plus 27, that's going to give me 32/9, but that's a complex fraction, so we're going to need to rewrite that. So that's going to end up being 9/20 minus 9/32. So it looks like my LCD here between 20 and 32 is going to be 60. I'm going to have to multiply this by 5, this by 5. I'm going to have to multiply this by 8, this by 8. By the way, if anyone needs help finding that LCD of those two denominators, please check out my video on how to find the least common multiple. And now we're going to multiply 9 times 8. 9 times 8 is going to give me 72/160 minus 45/160. And when I subtract 45 from 72, that's going to give me 27/160. If I can get 27/160 on the other side of the equal sign, then I can show there is an equality here. I can show it's a true statement, and that way I will know that 5/9 truly is the solution. Let's check and see what we get on the other side of the equal sign here. Let me scroll back up. Okay, let's simplify this. First I'm going to have to square those 5/9 right there, so it's going to be 3 times the square of 5/9. 5/9 squared is 25/81, plus, now I can multiply 9 times 5/9. That's going to give me 5, because I can cancel out those 9s. And then I'm going to have here 3 times 25/81, but 81 has a common factor of 3. So I'm just going to go ahead and write here 27. So now I've got 1/25/27 plus 5/1. Let's multiply by 27 to get an LCD here. So we're going to have 25 plus 5 times 27. Get that real fast here. I got 135. 135, and if I add 25 and 135, that's going to give me 160. It's a complex fraction. We need to simplify that, so that is going to turn into 27/160. We did get a true statement, therefore we are 100% sure that x is equal to 5/9. This is the solution. We can write it that way, or we could write it with a little solution set. Braces, 5/9. Okay, and that's it. Alright, thanks.